What's up, you guys? Uzi here. I'm back with another video, and today I'm going over IPv6 and access lists. So IPv6, Internet Protocol version 6, came about in the late 90s, about 15 years after IPv4 came out. With IPv4, you had 4 groups of numbers that go from 0 to 255 for a 32-bit address, but with IPv6, you had 8 groups of hexadecimal numbers. These are 8 groups of 4 characters, and they can be either the digits 0 through 9 or the letters A through F. And these are 128-bit addresses, and their main purpose was to fulfill the growing number of addresses that were needed with the internet that was rapidly growing at the time. As you can see, there's not going to be any new versions of IP needed because IPv6 covers 340 undecillion, which is 3.4 times 10 to the 38th number of addresses, enough for everyone on Earth and all their devices. Here we have a breakdown of an IP version 6 address. Here we have the specific number broken down into what characters they are and what the numbers are in binary of those characters, and then we have how many bits they are, and then at the bottom here's the binary notation for the entire address. If you'll break it down and read it, you'll have zeros and ones, 128 of them total for a 128-bit address. These addresses do have improved security. Some say they're simpler. That can be debated though. These are some of the advantages: larger address space, better security, like I said, improved packet handling, no need for NAT, better support for mobile devices. Now, compressed notation is an important aspect of IPv6. These addresses are very long, so compressed notation is a way of simplifying them when you're configuring them. So to simplify them, you want to remove leading zeros, you want to compress consecutive blocks of zeros with double colons, and you only use double colons once. And here's an example. You have 2001 ODB8, then you have 0000 3 times in a row, then you have FF00, then you have 0042 followed by 8329. So first thing you'll do to simplify it is remove this leading zero. You'll take all these and you'll make them only 10. Then you'll take these two in front of the 42. You'll take those two and make them just a 42, and you'll leave the 8329. So now you have this, and you have this consecutive block of 3 zeros. So you'll just replace that with a double colon. Now let's say in the scenario where you had a 0:0 in the front and a 0:0 in the back, you only use double colons once, so you would choose the first one. Now let's say you had this same address, except instead of 42:8329, you had 0:0 again, which meant you had 3 back-to-back zeros in the middle and you had 2 back-to-back zeros at the end. You would use it on the largest group, so you would use it on this one still. But if the number of zero blocks was equal, you'd choose the first one in the address to simplify. And here we have some of the CLI commands for IPv6, very similar to version 4, except for these ones you'll just put v6 after IP. So in my previous episodes working with IP version 4, you'll see me run this command, show IP interface brief. With IPv6, you'll just do show IPv6 interface brief. Similar to this command, IPv6 root. If you want to ping something, normally for IPv4 we would do ping and then type in the address. For IPv6, we'll type in ping IPv6 and then the IPv6 address. So that's IPv6. IPv4 is still widely used, but this adaptation of IP is growing steadily. The internet's going to continue to expand, which means IPv6 isn't going to go anywhere. We're still going to need more and more unique identifiers and unique addresses as time goes on. And that in a nutshell is IPv6. Now we're going to switch gears and talk about access control lists, otherwise known as ACLs. So an ACL is a security feature that's configured on a router or a switch, and it's meant to allow or deny certain traffic based on certain parameters that you configure. There's 3 types of ACLs. You have standard ACLs where you filter traffic based off the IP address. You have extended ACLs where you use the IP address, or you can use the other protocols such as port number. And then you have named ACLs where you give the ACL a descriptive name instead of a number, and you use that name to identify the ACL. These are some access control lists, best practices, and common applications. Best practices, you want to place your most specific rules at the top of the list and then work your way down. And at the end, you always want to include an implicit deny. What this means is you're going to have your rules set out that you want your network to follow, and at the end, if nothing matches the parameters you set, you're going to just deny that traffic. And like I said before, common applications, they're used for security, filtering traffic, restricting access, controlling traffic flow, etc. And with that, you should have a good idea of what an access control list is. Now we can configure one. Okay, you guys, now I'm going to show you how to configure an access list. Over here we have 2 PCs connected to a switch, which connects to another switch, which connects to 2 more PCs. These are the commands we'll be using, but just take note that when you're making access lists, there are so many different variations of commands and configurations you can make. This is just kind of like a guide to show you at a first glance. So we'll start by going in the switch, and we're going to make a standard list first, so we'll use this command right here. So now I'm going to enable and configure terminal. Now I'm going to type in the command IP access-list standard, and I'm going to give it a name network. You could also give it a number from 1 to 99, but for this example, I'm going to give it the name network. So I'm going to click enter. And now just to show you, if I type in a question mark, it'll show you these are the different commands you can type in: default, deny, exit, no, permit, remark. So we're going to start with permit, and we're going to permit this network address. So we're going to type in permit 192.168.10.4, which is this network, and then the wildcard mask for a /30 subnet, which is 0.0.0.3. And remember, when we say permit, that means we're permitting packets from this IP source, but everything else will be implicitly denied. So I'm going to type in enter, and now I'm going to end, and now I'm going to type in show IP access -lists network to see if the network was created. And there it is right there with our list. And now that I've verified we've made this access list, I need to configure it on this interface. So now I'm going to configure terminal, and now I'm going to type in interface gigabit ethernet 0/1, which is this interface right here. Now to add this access list on the interface, I'm going to type in IP access -group network, and then either in or out. For this example, I'm going to type in out, and by typing out, I'm essentially saying that we're going to filter traffic leaving this interface, meaning any other IP will be blocked. So I'm going to enter this, and now just to test it out, I'm going to show you. So I'm on PC1, and I'm going to try pinging this network. And as you can see, I instantly got a reply. Now I'm going to try the same thing on PC2. I click enter, and this is what we want to see, host unreachable. That means our access list is working. What we did is we permitted this to go out of the network. So now I'm going to go back on the switch. I'm going to configure terminal. I'm going to go back into the access list. Now I'm going to allow this network, 10.0 network. I'm going to click enter. Now I'm going to try this ping one more time, and now we get the reply. So that is how a standard access list works. You use it to block or allow IP addresses to flow through the network. Now I'm going to show you how to make an extended one. I'm going to go to configure terminal. Now I'm going to type in IP access -list extended, and I'm going to type in network X for network extended. First we permitted, so now I'll deny something. Type in deny, and I'll type in a question mark. And as you can see here, for an extended list, these are all the different protocols you can either allow or deny. OSPF, TCP, UDP, ICMP, which is a ping protocol. For this one, I will do OSPF. And for this one, I'm going to deny any OSPF traffic, which is why I put OSPF 192.168.0.0 and then the wildcard mask. And I click enter. Oh, it's an incomplete command. So I'll type in the same command, and I'll add a question mark to see what I'm missing. Oh yeah, any or host. Okay, yeah, so then I'll just put any at the end, and I'll enter it again. And so now I'll end here, and I will go into this interface, fast ethernet 0/1, to add the access list on the interface. And for this one, I'll type in IP access -group network X in. No OSPF traffic will be coming into this network. So I'm going to enter that, and now I'm just going to type in a show run so you can see. And right here are the access lists we've configured so far. And so now I'm going to go on PC2, and I'm going to ping this network again. And there it is, host unreachable. That's good, it means the ACL is blocking traffic. Let's try PC1. And this end is pinging, that's exactly what we want. So now, let me go back into the extended network, IP access list extended network X. Now I'm gonna type in this command, permit. For this one, I'll do ICMP, which is ping protocol. I'll type in permit ICMP any, and I'll go back to PC2. I'll try pinging this network one more time. And boom, there it is, the ping worked. Notice that ICMP is ping traffic, it is not OSPF traffic. That is why the ping is able to work, but OSPF is still being blocked. And that right there is how you configure access lists. They are used daily in the computer networking world. They're very important to understand. There's so many different ways to allow or block traffic, and the more you work at it, the easier it'll become. And that's it for today's video, you guys. Thank you for watching. Today we went over IPv6 and access lists, two very important aspects of computer networking. Thanks again. I hope you learned something new. I'll see you in the next video.